All right, lesson number 1, understanding slope. So you are going to see this word a lot in this lesson and a lot next year and really throughout all of 8th grade. All right, so right now make sure that you have a pencil and paper and number your paper from 1 to 4. All right, our objective today, scholars will be inquirers as they determine slopes of lines using their knowledge of graphs and ratios while interacting with the mini lesson and independent practice. So some important vocabulary that you need to know. Some of it we've learned a lot about and some of it not so much. So ratio, we've spent a lot of time this year talking about ratios, which is really just comparing two different things. Vertical and horizontal. Vertical means up and down. Horizontal means side to side. Okay. Line, we're going to be talking about lines. There's that word slope again. We'll get into exactly what that means. And I'm going to be using the word steep here to describe the steepness of a line, or how up it is, or how flat it is. And we're going to be talking about like walking up hills, and that might help us understand slope a little bit better. Okay, so what is slope? So this is the technical definition of slope, and I will go through some examples with you. So slope is the ratio or quotient, so we're going to talk about the ratio today, of the vertical, so that's the up and down, right? The vertical change in a line compared to the horizontal change, and the horizontal change is side to side change in that same line. So how much does it go up versus how much does it move over? Slope tells us how steep a line is. So if you picture yourself right here at the bottom of this line, and you're standing at the bottom, and this is a hill, right? This hill looks very steep. It would be very hard to walk up this hill or climb up this hill. The ratio will tell us exactly how steep that is. The nice part is the ratio stays the same and does not change. So I'm going to go into that specifically in this next example. All right, finding the vertical change and horizontal change of a line creates a slope triangle. So we're going to be using slope triangles to help us find the slope of each of the line. There are an infinite number of slope triangles on the line. So you can pick whatever slope triangle makes the most sense to you, and if you do it correctly, you should have the same slope no matter what triangle you pick. Now I'm going to show you an example of that in a minute. The longest side should be the line. So if we look at our first slope triangle, you see a triangle with points A, B, and C. The longest side is the line that we're looking at. We're looking at this line here, the purple line that goes all the way through. And on this slope triangle, on ABC, right, we have the red side, the blue side, and the purple side. The line should be the longest side. So the purple is longer than the blue or the red. And one of the sides should be vertical. That's the red line, the AB, the up and down. And the other side should be horizontal. That's the blue side, the side to side side of the triangle. Okay, so let's talk about these. We have two slope triangles here, but I'm going to show you these two and then another one as well, and how they are all equal. Okay, so let's look at triangle ABC. We've just outlined it here. Okay, the vertical side, we're going to start at the bottom, and we're just going to count how many boxes up is it. So how long is this side? So if we start at the point, we're going to count 1, 2, 3, 4. So the vertical side is 4. And then we count the horizontal side. That's the blue line here, that's side to side, and we do the same thing. We start at the point and we count over to the other point. So it's 1, 2, 3, 4, 5, 6. Okay. Now we are looking for the ratio of the vertical side to the horizontal side. So we're going to put this in ratio form. So 4 over 6. Okay. And we are going to reduce that. So both 4 and 6 can be divided by 2. Okay. And this will give us the reduced form. 4 divided by 2 is 2. 6 divided by 2 is 3. And what you've done here is you've found the slope of the line. It is 2/3. Okay, let's look at the other triangle in here, and we're going to see that we are going to get the same slope. So we have triangle CDE, right? The longest side is the line, the purple line. We have a vertical side in red and a horizontal side in blue. We're going to look for the ratio of the red to the blue, the vertical to the horizontal. So the vertical side goes up 1, goes up 2. And the blue horizontal side goes 1, 2, 3. So the slope is the ratio of the vertical to the horizontal. So this one is 2/3. And you can see that we have the same slope, even though we have two different triangles. Okay. Now I want to do a third triangle, and I'm going to erase this so you all can see it a little better. Okay. And we're going to create a big triangle of both of these existing triangles. So we're going to go start at A, and we're going to create a triangle that goes all the way up here, and then all the way over here. Okay, so we have a big triangle here. The longest side is definitely still the purple side. It's longer than the blue, and it's longer than the red. So we're going to try to find the vertical side. So we're going to start down here. We're going to count 1, 2, 3, 4, 5, 6. So the vertical side is 6. And the horizontal side, all the way over to E, is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the slope is the ratio of the vertical, so that's 6, to the horizontal, which is 9. Now this slope looks different, but we can reduce it. 6 and 9 can both be divided by 3. Six divided by 3 is 2. And 9 divided by 3 is 3. So you can see no matter which triangle we use on the line, we get the slope is the same slope no matter what. So the slope of this line is 2/3. All right, let's get into some practice here. So we're going to start with number 1. Okay, so remember, slope tells us how steep a line is. So the way I remember this is I start on the very left side of the line, and I try to picture myself walking up that line if it were a hill. So on number 1 here, we can see this is definitely a hill, but it's not super steep. It would be a hill I would walk up without very much difficulty. Number 2 is very steep. This is a very steep walk. If I started down here and I wanted to walk up this hill, that would be a very difficult hill to walk up. And so that is a very steep slope, which means our slope will have a bigger number, okay? All right, up here we have these steps for determining slope. So if you get stuck on your independent practice, come back here and look at these steps. So the first thing we're going to do is we're going to create our slope triangle. And the nice part is we have 2 points that we're going to use. So we're going to start down here, and we're going to go up, and we're going to go over. And you can see we've created a triangle that connects the 2 points, okay? And then we are going to count, just like we did in the last example, the vertical change. 1, 2, 3. And we are going to count the horizontal change. 1, 2, 3, 4, 5, 6. 3 over 6. The slope of this line is 3 over 6. Okay, 3 over 6. On number 2, we're going to do again, we're going to create a slope triangle. So we're going to start at the furthest point to the left. So we're not going to start here, we're going to start down here. And we're going to try to draw a triangle that connects this point straight up over to this point. And you can see that's going to create a triangle. So I'm going to go straight up to here, and then straight over to the point, and you can see I've created a slope triangle. All right, let's look and count how much did the vertical side count for. 1, 2, 3, 4, 5, 6. And how much for the horizontal side? 1, 2. So the slope of this line is 6 over 2. I don't want you to have to worry about reducing these. So if you can find 3 over 6, you do not need to reduce. And 6 over 2, again, do not need to reduce for now. I just want you to be able to find the slope from the slope triangle. Okay, let's do 2 more. All right, I want you to try this one on your own. So go ahead and pause my video. And when you're done finding your slope, click play, and you can check your answer. All right, so we're going to start here. We're going to create our slope triangle by going straight up and then straight over. So the slope triangle is, the slope is the ratio of the vertical to the horizontal. So how much did it go up? 1, 2, 3, 4. And how much did it go over? 1, 2. Okay, a lot of students are in the past have mixed up the order. So sometimes they put 2 over 4, or they're not sure which one goes first. The up and down side, the vertical side, always goes first. So this slope is 4 over 2. Okay? All right, I want you to try this one by yourself again. So click pause, try to find the slope. So remember, it's the vertical over the horizontal. When you're done, click play, and we'll go through this together to see how you did. Okay, so we're going to start here. We're going to go straight up until it's level with the second point. And we have a slope triangle. So we're going to measure the vertical side, 1, 2, 3. And the horizontal side, 1, 2, 3, 4, 5. Okay, the slope is the vertical, the up and down, compared to the horizontal, which is side to side, the 5. The slope is 3/5.